Hi friends, today I'm going to explain about one of the important pillar of Azure, which is Azure ARM, Azure Resource Manager, which is infrastructure as a code component. So until now, I have made few videos to create various resources of Azure from Visual Studio or from the portal. So here is a playlist in case if you did not go through, please go through that like how to make the various resources from portal or from Visual Studio. Today I'm going to show you how to create those resources through the infrastructure as a code component, which is Azure ARM. Let us jump into our topic directly without any more delays. If you don't know what is infrastructure as code is usually used to process of managing and provisioning computer data centers through machine readable definition files rather than the physical hardware configuration or interactive configuration tools. Usually if you have to create any type of resources on Azure or even take your data centers, on-premises data centers, if you have to configure certain Docker container or virtual missions like VMwares and all those stuff, you need to usually do it manually, or you can also do it by using the code. That's where infrastructure as code comes into the picture. It will simplify a lot of tasks and it will save a lot of time as well. So you will just write the code once for the requirement of your infrastructure and you will execute that. Then it will build the number of machines you require based on your code. So there are plenty of advantages with this. You can definitely visualize like what are the advantages while you are executing through the code rather than going through the portal or the manual process. So anyway, I'm going to cover that as well. Now various options are available. At various stages we can use those options. I don't know if you heard about Chef, Puppet, Ansible or Salt Stack. These are like various infrastructure as code tools which are used as part of the DevOps process. In case if you have to deploy certain applications, you can completely write in your Ansible or Puppet or Chef, and then you can execute and deploy those resources. For example, you need 10 machines for deploying your UAT servers or 30 servers for your production. So you can write the complete things under your Ansible scripting and you can execute. That will be executed by your Jenkins. So your Jenkins will take the ownership and then it will execute Ansible script so that your machines are ready, and it will also deploy the code from the various GitHub or the other source code mechanisms. So now apart from that, you also have something called Packer, Terraform, Cloud Init. So they are used for various purposes. For example, if you take Packer infrastructure templating, you can use that for packing and stuff. Terraform to manage infrastructure, Cloud Init install applications and one-time configurations, and CF Engine and Vagrant are also the tools like which are used for various levels. Let us have the advantages of IAC. So one is reusability. Once you write the script, you can reuse the same for like you have written code for your development missions. The same code can be used for your testing, UAT missions, production, to deploy those missions. The only thing is like you need to change the configurations, how many number of servers you may need, and if you have different configurations for production servers, you may need to just change those things, except that everything can be reusable. Coming to the speed, compared to the manual process, if you have to go to, assume that you are going to go to the portal of Azure and then you are creating a virtual machine. It will take maybe 10 minutes for each virtual machine. Then if you need 100 virtual machines, it takes 2 hours. But here at a go, you will run a script and that all machines will be ready within very short time compared to the manual process. Much faster than manual process. Coming to the cost, definitely you can save a lot of cost as well. Because you are ultimately saving the cost of the person. Like every time if they have to deploy manually, it will take a lot of time for the person. That means you're paying for the person, right? Even in that case, it saves a lot of cost, and the maintenance will be much easier because you can maintain your own source code control for that, and you can keep on update those things, and you will have a track like when you have made changes to your infrastructure or what kind of versions you have managed, what kind of softwares you managed maybe 1 year ago. All those things can be tracked. So while deploying, in case if something goes wrong, Even the rollback is possible when you are doing it with the scripting. Risk, like say if there are any security violations when you are doing it through the portal, probably there could be some security violations, but while executing the code, you know what is a script, and only within the script limitations that will run, not like extra resources or something will be compromised, nothing else. Like what are the privileges given to the source code or the infrastructure as a code, that will be executed and only those resources will be up. So coming to the next one, ARM versus Terraform. So there are multiple options, right? Even Terraform can also be used to deploy your infrastructure to Azure, and Terraform is actually multi-platform, like it can be used for AWS, Azure and GCP as well, but whereas ARM can be used only for the Microsoft Azure, nothing more. So let us see what are the differences, or let us have a comparison. So coming to the ARM, that is developed by the Microsoft, Terraform is developed by HashiCorp. Coming to the ARM, it can be used only for Azure, and coming to the Terraform, it can be used for the multi-platform. And the format ARM uses is JSON, whereas the Terraform uses HCL language, its own language created by the HashiCorp. Coming to the code in the ARM, it's like bit messy because it's a JSON format, but still it is very much maintainable. But it's messy compared to the Terraform. It's not like general messy. It is easily manageable, organizable. Coming to the Terraform, it is easy readable and easy to learn as well. Whereas even ARM is easy to learn. It's not like big deal to learn. I'm going to show you the simpler ways and straightforward ways to deploy the solutions. Deploy the templates. So before you deploy the solution or the template, you don't want to mess up with the stuff, right? So you always need to validate that. Even the validation is possible on the ARM, like deployment validation. Before you even execute that, you can simply validate, and if everything is fine, then only you can go to the next step. Similarly, Terraform also has the deployment validation. ARM can be executed through the portal. Portal has the option. And you also can use a Visual Studio Code, which is free. You can also use Visual Studio. There are plenty of options to execute your templates, ARM templates. Whereas Terraform has only one option, that is IntelliJ IDEA. So IntelliJ, by using IntelliJ, you can add the HCL plugin, and then you can start writing your Terraform code for the Azure. Assume that you have written maybe like 100 lines of code to create the resources on the Azure, but in the middle something got broken. So our expectation will be like it should not continue, rather it should roll back everything whatever it created so far until that particular line of code. So if that capability is not there, you will be losing a lot of money, and again you need to figure out like what are the things created by that executed script. It will be really hectic to figure out all those stuff. So rollback capability is one of the major feature, an important feature, which helps you in a lot of the ways. So that is also supported by ARM as well as Terraform. And policy as code is also supported by ARM. So in case if you have to implement some policies, so you can apply those policies in the resource level or resource manager level or resource group level. So those all can be done by using both ARM and Terraform. You can also deploy the blueprints. You can also do the CI/CD integration to automate your release pipelines. This is one of the important question usually people ask in the interviews, especially if you are attending administrator or kind of co-developer roles in the Azure. So that's why just have a look like why you want to go with the ARM or Terraform. Terraform definitely it is good to have because it's a multi-platform, but in case if you want to go with the ARM, it got its own advantages, like there are plenty of ways and easy ways to write the code. So coming to the next one, ARM handling request. So how ARM handle the request? It can handle the request from Azure portal, I already mentioned. It can also handle the request through the PowerShell. It can also handle the request through the CLI, and it can also handle through the REST clients in case if you are writing some application and through the application you want to create your resources. So then also you can just access the APIs, and then you can create what are the required resources. So you can see here, these are the 4 different channels, and the SDKs are there for the PowerShell and Azure CLI. And coming to the type of resources you can create data stores, web apps, virtual machine, service agreement, whatnot. Like most of the resources can be created on the portal by using ARM. So you can also configure the authentication. So this is how the handling the request will happen on the ARM side. Coming to the ARM scope, it usually goes into this hierarchy. For example, if you are applying a policy to a resource group, whatever the resources available under that resource group, all those will be taking that policy. So for example, if you take its subscription level, under the subscription you have maybe 10 different resource groups. All those 10 resource groups and the resources which are under each resource group also will take that policy. That means it will be applied to all those resources, like maybe kind of permissions or some kind of compliance or something like that will be applied. This is how the hierarchy works. Management group, if you apply to the management group, then it will apply to all the subscription which is under the management group. So coming to the next one, ARM template file. So these are the main components of your template file: parameters, variables, user defined functions, resources, and outputs. I'm going to show you in the code as well. So parameters usually used to just take the values. For example, you can just declare a value here under the parameters, and you can use it under your resources. Provide values during the deployment that allow the same template to be used with different environments. Variables usually define the values that can be reused or that can be dynamically changed during your code or scripting under the resources. Define values that are reused in your templates. They can also be used constructed from parameter values. Definitely you can utilize the parameter values, and you can dynamically change that variables and values to that particular variable. Coming to the user defined functions, they create customized function that simplify your template. In case if you want to just define it as a function and then you want to reuse that in your resources, then you can use a user defined function. And then coming to the resources, this is the main part of any template. This is where you're going to create your storage or VM or any other resource as part of this by following the certain syntax. So specify the resources to deploy, and the properties which apply to the appropriate resource also will be taken care under the resources. Outputs, in case if it is returning the values from the deployed resources, that all can be printed as part of the outputs. These are the 5 main components, or the only components under the ARM template file. So if you know about this 5, then you are almost there. Under that, again, you have plenty of different properties which need to be considered. Then you must need to know what VM got, like the location, or the skill set, or the availability set, or availability. All those properties need to be defined under that. No need to worry. Tools will provide you the predefined schema or the structure of the resource. So we had enough talk. Let us just jump into the action. I'll just show you where you can start your templating, but in my next video I'm going to cover by creating a resource. So let us just go through the portal. In the portal you can search for the template. I just logged in into the Azure portal. You can go to the templates. You have 2 different ways: templates or deploy a custom template. Just click on the deploy a custom template. That's where you will be able to see create Linux virtual machine. That means it got a predefined key structure which you can directly utilize by changing the properties. Create a Windows virtual machine, create a web app or SQL database. So let us just click on this just to see how the structure works. So just fill it up all this and you will be able to get it. Now I'm going to just take to the Visual Studio Code. So yeah, so this is a code. You can just simply right click and add new file, maybe template to show or demo.json file. Always use a JSON, okay, otherwise you don't get IntelliSense here. I'm just simply writing ARM, and so the first one, select this. I talked about schema, parameters, functions, variables, output, resources also. So these are the main components under any template, right? So just by using this you will be able to write. Now you may say, how can I just define the resource? Go to the resource, inside this bracket, square brackets, you can start typing ARM. So what do you need? ARM VM Windows or Ubuntu or some storage. So I'm going to take VM Windows. Everything has come under this. You can check. I didn't do anything, so directly it has come. And you can start changing the parameters. Similarly, if you want to define some storage, so you can go ahead and start writing. So you can start writing. In case if it doesn't come out, simply press Ctrl and space, then this whole thing will come. Azure storage. So you got it for the Azure storage also. This is how you can start writing templating and you can deploy it. Now, so if you did not install the extension on the Visual Studio Code, it doesn't work with the IntelliSense. What you need to do is like go to the extensions here and then check for the ARM. Check for the ARM and see if it is installed. This is for the this is by the Microsoft. Try to install that. I already installed, that's why I'm getting all the IntelliSense. In case if it is not installed, it doesn't work. So after Visual Studio Code installation, you also need to install this extension. So the third way which I mentioned is Visual Studio, right? So let us go to the Visual Studio Code. I already opened this. In case if you do not have the templating here, then you have to go to Manage Extensions and then try out installing that ARM templates. So as I already have, as part of the Visual Studio 2019, I'm just directly going to the new project and then here select Azure Resource Group. Okay, in case if it is not there, just simply search it and find out. So next, I'm just saying for demo, ARM for demo, create. So here you can select a blank template or you have different templates here. First, let me go with the blank template. Okay. So you can see I got my JSON file, Azure deploy. Just taking a few seconds to load. So by default, I already got the schema as part of Azure deploy.json, and deploy Azure resource group.ps1 will be helpful to deploy your ARM template to the Azure portal. That means it will create the resources whatever you had defined under the ARM template here. Okay, so this is only just to deploy the things to the Azure portal like storage, VM, everything. So let us just go here and you can see the left hand side, parameters, variables, resources, groups, outputs. So now I want to add a new resource. Just simply right click on the resources, add new resource. Let us start with the storage. So storage account, simply click on it and write a name for it, storage for ARM demo. Add. So I got the script, I got the parameters. So this already set up the default value, and then what are the parameters is required for creating a storage. All things have come. If you want to change any parameters like location or the type of the redundancy, LRS or ZRS, all those things can be changed and you can start building it. Definitely it got some errors, I need to fix them. I'm going to record one more video where I'm going to fix and then deploy that as well to the Azure portal. So my third video will cover creating the VM, and also I will try to cover the creating number of VMs in ARM template. So thanks for watching my video. This is just an introduction, but I'm going to continue with more templates.